Heisenberg's uncertainty principle. According to this principle, it is not possible to measure both the position and momentum of an electron or any other particle at the same time. There is always some uncertainty, that is delta x in the specification of position, and some uncertainty delta p in the specification of momentum. The product of delta x and delta p is the order of h cut, that is delta x into delta p equivalent to h cut. Question 1. A more rigorous treatment gives delta x into delta p greater than or equal to h cut by 2, where h cut equal to h beta 2 pi. Case 1. If delta x equal to 0, that is position of particle is measured accurately, then from uncertainty principle, delta p equals to h cut by delta x equal to h cut by 0 equals to infinity. That is, in measurement of momentum of a particle is infinite. In other words, momentum of particle cannot be measured. Second, if delta p equals to 0, that is the momentum of particle is measured accurately, then delta x h cut by delta p equals to h cut by 0 equals to infinity. That is, uncertainty in the measurement of the position of the particle is infinite. In other words, the position of the particle cannot be measured. Now, if an electron has a definite momentum pair, that is delta p equals to 0, by the de Broglie relation, it has a definite wavelength lambda. A wave of definite single wavelength extends all over space. By Bohr's probability interpretation, this means that the electron not localized in any finite region of space, that is, its position is uncertainty. That is, its position uncertainty is infinite, that is delta x tends to infinity, which is consistent with the uncertainty principle. Davison and germer experiment for the verification of de Broglie waves. This experiment was performed in 1927 by C.J. Davison and Elliot Germer and got Nobel Prize in 1937. And this experiment also independently performed by G.P. Thompson in year 1928. The experimental diagrammatic setup of experiment is shown in figure. Uh, this is a cylindrical metal cylindrical metal with a hole in middle part, and this is the filament of electron gun. This is connected to the positive terminal of a battery. This is the variable battery, and negative terminal of the battery is connected to the electron gun or uh, electron emitting filament. This is the filament of electron gun where electron is emitted, and this is a target made of nickel plate. This target is made of nickel, that is nickel plate, and this is the movable collector where electron is collected and measured by galvanometer. The value of collected electron is measured by galvanometer. Now, when the potential difference between these two plates is applied, that is cylinder and the filament or electron gun, then electron is emitted from the electron beam is emitted from the filament, and which is collimated passing through the cylinder and strike the target and diffracted by this target, and this movable collector collect this diffracted beam of electron, and at a given angle and given voltage, a peak in electrons is observed, that is, its intensity is maximum for a given direction and given voltage, and thus this verifies the wave nature of electron, that is only wave have a maximum intensity at some point and minimum intensity at some point. Now in experiment the accelerating voltage is applied was 44 volt to 68 volt. A strong peak in the intensity of a scattered electron for an accelerating voltage of 54 volt at a scattering angle theta equal to 50 degree was found. The appearance of this peak in a particular direction is due to the constructive interference of electrons scattered from different layers of the regularly spaced atoms of the crystal. From the From the electron diffraction measurement, the wavelength of matter waves was found to be 0.65 nanometer. Now we have from theory de Broglie wavelength of electron as lambda equal to h by p equals to 1.227 divided by under root b nanometer equals to 1.227 under root 54 equals to nanometer 0.167 nanometer, which is in agreement with the experimental value. This is the theoretical value, and we observe experimentally this wavelength of electron, and theoretical and experimental value matches, and thus uh, wave nature of particle was verified. Our atomic structure. Thompson model of atom. The first model of atom was proposed by J.J. Thomson in 1898. According to this model, the positive charge of atom is uniformly distributed throughout the volume of the atom, and the negatively charged electrons are embedded in it like seeds in a watermelon. Thus, model is also called plum-pudding model of the atom. This is shown the atomic Thomson model. Positive charge embedded in the negative charge particles are embedded in the positive charge. Now, alpha particle scattering proposed by Thompson and Rutherford in 1906. This experiment was performed by Hans Geiger and Ernst Mast in 1911. The diagrammatic arrangement of experiment is shown. That this is a gold foil, and this is the source of beam, source of alpha particle, which is put in the lead box, and the energy of all alpha particle was 5.5 mega electron volt in the experiment. And a lead box in which bismuth 83214, a radioactive element, was put to emit alpha particle. And this is the goal, and this is the screen where after scattering the alpha particle is observed. Now from this experiment, what observation was observed, we will discuss it. First observation: most of the alpha particle pass through the gold foil undeflected. Some of the alpha particles, about 0.14% of incident alpha particles, were deflected through angle greater than 1 degree. Third, in 1 in 8,000 deflected by angle 90 degree or greater. 4. few alpha particles retraces its path. Rutherford model of atom, that is Rutherford model of atom was based on this above experiment. On the observation of alpha particle scattering experiment, Rutherford proposed his model of atom according to which most of the space in atom is empty. This is atom, and particle is going. Most of because most of the part of atom is empty, so particle passes. Most of particle passes undeflected. Second, most of mass and entire positive charge is concentrated at the center of atom, which is called nucleus. The electron revolves around the nucleus in different orbit. Fourth, the radius of an atom is about 10 to the power minus 10 meter and of nucleus is 10 to the power minus 15 meter. Now alpha particle trajectory. The trajectory traced by an alpha particle depends on impact parameter B of collision. The impact parameter is the perpendicular distance of the initial velocity vector of the alpha particle from the center of the nucleus. This is the center of the nucleus and this is the initial velocity direction of the alpha particle. Here it deflected due to the effect of nucleus. So this distance, parallel distance between center and the direction of initial direction of alpha particle will be called impact parameter. Electrons orbit in Rutherford atomic model. The electrostatic force of attraction Fe between the revolving electrons and the nucleus provide the necessary centripetal force Fc to keep them in their orbit. Thus, for a dynamically stable orbit in hydrogen atom, Fe equals to Fc or mv square by r equals to 1 by 4 pi epsilon naught E square by r square. This implies r equals to E square by 4 pi epsilon naught mv square. The kinetic energy of electron k equals to 1 by 2 mv square 1 by 2 m into E square by 4 pi epsilon naught m into r. K into E square by 8 pi epsilon naught r. And electrostatic potential energy U equals to 1 by 4 pi epsilon naught Q1 Q2 by r equals to 1 by 4 pi epsilon naught plus E minus E by r equals to minus E square by 4 pi epsilon naught r. Thus, the total energy of the electrons in atom is E equals to K plus U E square by 8 pi epsilon naught r minus E square by 4 pi epsilon naught r equals to minus of E square by 8 pi epsilon naught r.